Example 2.4. In this example, water in a tank is pressurized by air and the pressure is measured by a multi-fluid manometer, as is shown in the figure. The tank is located on a mountain with an altitude of 1400 meters where the atmospheric pressure is equal to 85.6 kilopascals. The goal of the problem is to determine the air pressure of the tank if the values for H1, 2, and H3 are given, as well as the density of water, oil, and mercury. In order to calculate the value of pressure at point 1, we're going to use the information that we know at point 2 and the elevations within the manometer and also the different fluids that we have. So we said P1 is equal to P2. And then from point 2 to this point, we're going down, therefore the pressure increases, and we go simply gamma times H3. The gamma that we have from this point to this point is going to be mercury, so we write it this way. From this point to the next one, we have oil, and also we're going up, therefore the pressure decreases, and we write it as negative, and we simply write gamma of oil times H2. Then from this point to point 1, we're going up, therefore the pressure decreases, and we have negative. The fluid that we have from this point to here is water, so we have gamma of water times H1. Since the problem provides the densities rather than the value of the specific weight of the fluids, we're going to rewrite this equation as such. So P1 is equal to the value of P2 plus G, density of mercury, times H3 minus gravity, density of the oil, times H2 minus gravity, density of water, times H1. Since we have gravity in the last three terms, we could factor it out, and we could simply say P1 is equal to P2 plus gravity, density of mercury times H3 minus density of oil times H2 minus density of water times H1. Now let's substitute the values. P1 is equal to P2, which is equal to 85.6 kilopascals, plus gravity, which is equal to 9.81 meter per second square. The density of mercury is 13,600 kilograms per meter cubed, and the value of H3 is equal to 0.35 meters. Okay, so we're gonna continue factoring this, and then equals minus the density of oil is equal to 850 kilograms per meter cubed, and the value of H2 is equal to 0.2 meters. And then the last part, which is water, which is 1000 kilogram per meter cubed, and the value for H1 is equal to 0.1 meters. We close this up, and then we simply get P1 is equal to 85.6 kilopascals plus 44,046.9 pascals. Notice that for us to be able to add these two terms, both of them have to be in the same unit. So either you multiply this by 1,000 to make it into pascals, or you divide this by 1,000 to make it into kilopascals. At the end, your answer is going to be P1 either 129,646 pascals, or 129.6 kilopascals. Please make sure to go back and do all the process, be able to cancel all the units, and remember to add only units that are the same type, either kilopascals or pascals. Please also note that the value obtained for P1 is an absolute value since it uses the atmospheric pressure at point 2. If we're only looking for the gauge value, then we simply take the addition of the last terms, therefore is equal to 44,000 pascals.